Good day, guys. How are you doing today? So today we continue from where we stopped. The previous lectures we have looked at some questions and example. Today we start continuing our lecture series using recursion. Now let's look at what recursion is and how our program is organized. Now we look at this question in our previous lectures. Our previous lecture. Now let's continue from what is recursion. Recursion is a programming technique where a function calls itself either directly or indirectly to solve a problem. A recursion typically has two parts. It has the base cases, the recursive steps. In the base cases, we have one or more conditions that stop the recursion. Without a base case, the function will call itself indefinitely, leading to a Stack Overflow error. Can you imagine that? So there will be a base cases here where we should select what happened when we have this and what happened. And the other one also have recursive step. This one where it calls itself, the part of the function where it calls itself, usually with modified argument, what that move closer to the base case. I think you understand it more better when we come to the example part of it. So let's calculate the sample of a factorial. A factorial, 2 factorial will be what? 2 times 1. And we can also get 1 factorial will just be 1 as well. 1 is 1 times 1. So we check sometimes in the code that if the result, if the input value, if the user supplies, maybe the value to be just 1 or 0, just return what? Just if it is 0, just return 0. If it's 1, just return 1. Understand? So look at the formula here. N factorial in mathematics. See, n factorial is what? N minus 1, n minus times till the time you get to n minus 1. In the recursive definition factorial, let's look at the recursive definition. Let's assume it is the name of a function called factorial f, taking in the argument of what? N. N can be any value, can be any numbers. Then we now multiply this n, that same value, assuming it is 5. Assuming our n is 5. Then at the end of the day, the function will also have minus 1 for me. I'm going to say a sample of it. So then function again, the next step, this function again will return the what? The value of this, this minus 1, right? Or we multiply the minus 1 from the value n and multiply with the initial given value. So that is how it goes this way. You can see here. So on the base cases, factorial equal to 0 equal to 1, and often factorial of 1 is equal to what? 1. So we don't put our code into what? To avoid leading to what? Stack overflow exception. Then let's look at this code here. For example, see this code here, recursive function factorial. We use long factorial here in case maybe the user want to return the value will be long later on due to the multiplication values. Understand? So we have to use long so that we get the correct answer. You can decide to just use only long alone. So then we have this. We have this code. We supply the integer n. I'm going to demonstrate for us now. And we also have n minus, or if n is less than 0, it should return minus 1, indicating what? An error, right? In case the user will enter maybe minus values. So, and else, if n is equal to 0, that means what the user here enter is equal to 0, or n equal to 1, just return 1. Either of these should be return 1. X. The remaining is that what? We just multiply the value of this n minus 1 till it get to what? The value set to 0, and the value is stays. Let's look at our code here. Let's check. Let's demonstrate what just happened here. Let's look at this one. Let's just call recur 1. Let me just name this one to be recur 1. Rec 1. I'm going to see. So from this, I can have include scio.h. Then you can have our functions. I think we discussed about function prototype and all that thing else. Let's begin to use them. Now let's just we use long the other time. Then we use we call it factorial, right? You can call it anything you want to. But taking in an integer value can be integer. You can give the value, and you can just leave it this way. And int main, right? So return 0 because you have int here, so return 0 here. Now let's implement this function we have, the function we have here. Long. In case we just test for small values, let's just use small values. You can test that one in. Let's just make it an integer value. Let's just test for small value. So int just factorial. So let's just call it what? Taking integer of n, only one parameter. Remember, if I change the value of this, remember this will all be affected here. If I also supply another one called int, again it will be int2. My compiler will flag an error. Can you see? They are incompatible, right? Can you see? Incompatible type. In case you are wondering, where am I getting this kind of thing? Show me here. Just come to your marketplace and your VS Code, and search for error lens. Once you install it, automatically it will be showing you the indication. So we have only one parameter. So if you also want to make it 2 parameter, you can just take another int value. The error will disappear. But since our factorial is just taking only one value from the user, so you can as well also declare the variable and put n here and put n here as well. So it also work in case you put s here. So you can you see how the same thing. So just leave it at int here. So let's just continue. Let's check if n is less than 0, then it should return what? -1. Understand? Then else if, use the else if ladder here. Else if the n equal to what? 0, or we use the logic 0, we use the logic and or the logic or to also check the what the user enters. N and n is what equal to 1. If you just return 1, it should just return 1 for us. So whenever we multiply anything that will return by 1, so we're going to get the reason why by the time the user gets to 0 is that all the value will not turn to 0 back. So we have just to return 1. Also, if we also have n equal to 1, just return 1. In case that all the values, if we just leave it as, if we leave the 0 the same way, all the value multiplied we just turn to 0. Understand? We cannot just return this. We can also put s in this. We can also put s here, just return this value. Let's just do it normally. So s just return that is what? N, the value of n, understand, multiply by, call this factorial itself. The value is taking in an integer number, then we put what? N minus 1 there. So because we don't want to put 4 here, because anytime the value of n will have reduced by the time the function is calling itself. Understand? Then we now have what? We now come to our main function here to look at it. Then let's look at what? Let's calculate what is n factorial. N factorial, let's look at it here. For example, let's now call, let's just put it here and just, let's just say, int f, just call factorial, just give it the value of 5, for example, and let's just print our value here and say, value this of what? This factorial is, just leave it this way, percentage. just give the value. I'm having two placeholder here, so I give the value of the two placeholder. My first value here is f, and in case I have my number, maybe int number, int n. If n is equal to what? Maybe for example, we give 5 here, and we now give our n here. So we can just say, okay, our n and our f. Then we compile this now. Just can just compile. We compile it now. What do we have? 5 factorial is equal to 120. Understand? So can you see it compile? It should completely call everything after the other. You can also want to show the step. By showing you step, you see how it's being calculated. Understand? You can also use other methods to do that. If you don't want to do that by just placing them inside. I'm just comment this one out without doing it. Then you can just for just shoot off maybe for int I equal to 0, I less than equal to what? N I plus step of 1. Then you can print f, the value of the word the user entered, multiply. Maybe okay. Just we want to see this factorial. You can just put this one factorial here. Just have the tab, then equals %d, the value of the %d, then give it a space, and then we have what's the value of our n factorial or high factorial will be what? Days. Then what will be the second value of it? That will be high. You can go it. You can just go from this, from 5. Let's just give it the end value of n to be 5 this. Then we move from I less than greater than the what? 0. Then I minus. We go down the way. What is going on here? Okay, sorry. So we should have, should be clear now. So we have it this way. Then we have, all right, I factorial. Then we have, why do you not get the value of it? The next value of that. So you can also say, okay, I multiply I minus 1. I multiply I you check here. Also check here if I equal to 0 or I equal to what? 1, then return 1. We should just say okay. I can just say okay. I equal to what? Just I equal to 1. Just say I equal to what? 1. Then okay. So now I can just compile. What's going on here? Okay. Now I can compile now. This function is not tampering. I'm not tampering with this function now. For clarity's sake, I can just comment it out. So for clarity's sake, I can just comment it out so that we know that we're not tampering with the code. Let me just see. Can you see? It's a 5. This is our answer is not correct. For this is not the correct answer for now. 5 factorial should be more than this, but I put it in its form of step, but it should be total, in total. This not be 5 factorial. That will be 5 multiply in summation. 5 multiply, this should not be 5 factorial. 5 factorial should be okay, guys. I tried to pause the video and try to figure out what the problem is. So there was a mistake in the code I wrote earlier. Now, therefore, we can easily create a value, just an integer value called sum and assign 1 to it. We cannot put it as 0 because during multiplication, the result will be 0. So we can just put 1 here. Then we can easily come here and put what? Let's sum them together because this will go down from 5 to 4 to 3 to 2 until you get to 1. So let's just sum let's multiply equals to what? I. This is the same thing as sum equals sum multiply by I. So this is the same thing as the. If you check our previous lectures, you get it there. So we are multiplying and we are multiplying together all the values, iterating them. So I'm storing them inside the sum of I. So I just call it. You can just see this may be super ambiguous. So just call it for a lot. It's not sum, so let's just call it results. So just call it here. So then we have then from there again, so we cannot compile our code here. If we compile our code here, you should get 150 or 120, for example. The reason why we're not getting it because we are not printing them out yet. Mind you, we're not printing out for the loop. We already have the result here. So we come out of the loop, print. That will be what? Our n factorial, our %d factorial equals %d, which is what? Our results. Then you can have it in new line here. So let's compile the program now. Let's see what we're going to get. So we have 120. Oh, I'm getting an error here. So for %d, which is one of the actual values, I'm getting negative value. Okay, 5 factorial of the result. The value store results of this multiply equals to high. Oh, sorry, I'm supplying one argument there. We have also what of I. What's our n? We have n and result here. So let's compile it again. I place 2 placeholder. I'm supplying one argument. So that will show me the result and the other negative value. So can you see? Of 5 factorial equal to this. And we have this now. Of 5 factorial is equal to this. But in the case that we want to be seeing each iteration as it goes, that may also come to this our function here as well. You can also come in just uncomment this, Ctrl//. So uncomment it. Then we can easily come to our what? To the main function here. Can just comment this one out. So we don't need this one for now. How do we place it? Then remove comment this. We're doing this one for now. So they're not working. We just remove it so that you will not be confused. So just remove them. So we don't need this one anymore. We want to iterate all those factorial as they go. Then we can easily pass in our result here and say results. Let's just say, okay, maybe this is integer value. Just put this one. Just put 0 here. You can easily just even need the result value here. Print f, our result value. But yeah, %d factorial equals %d. Should have it in new line. We should have it in new line to proper visualization. So let's just see this. Okay, then I'm passing in two values now. All two values I'm passing in. I'm passing in. No, I'm passing in my high, and I'm also passing in the function factorial, which is taking the parameter of I. So then I hand it here. Let's see. Can you see? Yeah, which is, yeah, this is what I'm looking for. Can you see? 5 factorial is equal to 120. 4 factorial is what? That is 4 times 3, 12, 4 times 2, 24, 4, 12, 4 times 1, which is what? We'll get it to be just 1. 4 times 3 is 12, times 2 is 24. Same thing, 3 factorial, 3 times 2 times 1. We'll get it. We get the result now? We get the result here this way. This is what is going on here. We call the functions inside the loop statement to be able to solve the problems. They also help us to find the modularization. Like we have a function here already. This function prototype. Yes. This is what? Function prototype, type or declaration. So we have it here. So we don't have this. We don't need this ones anymore. So, and it can be anything. You can just change to 10 factorials. Let's run again. Check the value of our n. Can you see 10 factorial is this, 9 factorial is this, 14 factorial is this, which makes sense. Then therefore, we start from the iteration from the n less than, the first initial value will be n equal to 10. Then I is still 10, which is greater than 0. I here, you now minus decrement by 1 is also the same thing as saying, okay, I will be I minus 1. In case you are confused, you can do it this way, it will work. Or you say minus equal to 1, it's the same thing, it's going to work. So it depends on your own way you what you like. So, and we check if we get to 0 or mistakenly get to 1, just give us I equal to 1. Then we print the value by calling this function. You can still assign inside a variable and create another variable, but that doesn't necessary. That will not be necessary since it's returning an integer value as well. So, and then we now move to our slide back. We also have recursion. You can also demonstrate the sample here. Let's look at the key takeaway here. Recursion provides elegant solution for problems that can be broken down into smaller, self-similar sub-problems. Let's see some common application of it. Tree traversal, e.g. in order, recorder, post order. That means in order, want something to be in order, also want something to be ordered. You can see the way the thing was ordered down. You can also use them in kind of sorting algorithms, or mind sort and quick sort, to data structure programming using C, be able to see those things there. Also see mathematical calculation, factorial, Fibonacci series. You can also accompany that using the Fibonacci series. And what is Fibonacci series? The video will be too long, so I will just demonstrate it for us. But if the Fibonacci series take into parameter what the addition of the first one and the second one give us the what. Maybe I should just demonstrate it if you don't mind. Fibonacci series, just call it rec2. Rec2. Let's see. Oh, so sorry. We just need it. We just need to do this. Okay, let's just call. We don't need to. Let's just call something here. Just Fibonacci. Fibonacci series which taking in will be our n. Integer value n, the first value, for example. Then I think I have the code here somewhere here. So I think I have the Fibonacci series. just trying to look at it. We are waiting. Okay. Since I don't have it, let me come back to my code here. Fibonacci series just be, for example, if I have a series like this, let me just comment it out. 1, 2, 2, 3. The previous two addition will give us the next value. Understand? Then we have 5. Listen. So this one will be 5. 2 plus 3 will be 5. This one will be 8. The next one will be what? That will be 13. 13. You can maybe you do that so that to avoid the video long. But if you still request me to do that, maybe please you just let me know. So you can check the same condition we check here. Please just you can try it. If you're unable to solve it, please let me know in the comment. I will just solve it and send the code to you to avoid providing something too long. Then we have different series. Okay, we also have recursion, consideration, look at the efficiency, memory usage and consume more memory stack, complexity. But also see, let's manage code complexity, the need for organization. As program grow, keeping all code in a single .c file becomes unmanageable, difficult to navigate. So now we are in the program structure now. We want to separate our code. Imagine all our code are in one functions. All our code are in one main program this way. Our line of code is now getting to thousands of codes. So how do we manage them? You can use in C, we don't have classes like C++. We can manage them through the help of header files, where we have some of our prototypes. Our header files contain only declarations. So what do I mean by header file? This one also what .h is called a header file. You can also come to your folder here and create a folder called maybe headers. For example, you can just name it headers, understand? And you can have anything. You can just have any file there and name it maybe sample.h. So where it contains all the header files that you will be needing, understand? Can be something else. So let's continue in our slide. Let's continue in our slide. So I will not drop the gun. So a header file supports splitting project into multiple files and contain declaration. With what we have the source file, we compile them in our source file. We include it in our in our header file. All this .h as well we are seeing here. They are also header file. It is standard input output. STD means standard input output header files. It's coming from our compiler. That one is coming from our compiler. So then you can also invoke them. The header files, the purple header files typically contain declaration needed by multiple sources. They declare what exists but don't usually define and implement it. So you don't usually implement in the code. Doesn't mean that you cannot do that, but you don't implement in the code. Let's try to refactor from our previous code, and let's just put it inside an header file. For example, let's just give it a simple header file there and move this. Okay, if, for example, use this command, if not defined, then if not defined, maybe for example, function prototype, we want to put all our function prototype here. So we don't need to be creating some other function prototype. Maybe let's just call it what? Let's just call it photo. Then let's define some macro photo. In case the use of this if not defined to help us to keep check whether we have defined this, if not, define it so that to avoid code duplication in our code. Then we have end if now. So now we have this now. So we have something called int factorial the other time. Factorial. You can even include our std other file, include std.io.h. And also our function type is taking in int. Then we have all our header here. So then we don't even need to include other ones. Just come to our code here. Just come to our previous code. We have function type here. Can just remove this, all these two. We don't need it anymore. I'll just include what our headers. I think we have headers, right? Headers. So that will be any just headers. Use this form. Headers. Okay, so headers. Sample.header. So we are included now. Let's try to compile it again. Let's clear this place. It's a header files. No file in the directory. Okay, I think we use this form. Use the form to what? Include it. Yes. Not. So now let's try. Good. Can you see? We still get the same result now. We get the same result. You'll be thinking of something. Let's just make this one with 7. 7 factorial should give us now 7 factorial, we get it here. So all our further, we have our what? All our header and other prototype. So it's not complaining that it's not seeing the factorial here. It has been included in the file here. If you are creating your own custom header files, you use the double quote here to include it. But if you are including it from the standard library, you use the angle bracket to include it. Just our previous stdio. So then we have macro definitions. So can you see define here? Sometimes you can still define some kind of macro in case you want to have some, maybe you want to have include, some macro define maybe pi, also to create a constant value. Maybe our value of pi is 3.142. Then we can call it, also use this one to calculate the what. Then multiply the result of this by pi. Then if we also want to multiply it by pi, you see that we can still use it to do. I'm just doing something here so that you can get the value here. Let's just see. And you see, the reason we are getting more than negative is that we are getting more than the actual value of a byte. So we are getting more than the actual value. Also, we are getting more than the actual something. So okay, now we have so we have declared our, then for type definition, type def struct enum. I'm going to get to type def struct in future for custom user, for custom type, for enable struct enables you to what, to have some multiple type created at the same place. Maybe so we have it int alone, int age. You can also want to create some advanced type, like a user, a person. A person will have a name, so a type can contain several types. So that will enable you. So we also have this. So look at it. See our header files of what I've demonstrated. You can also look at the slide. If not define my header, then you define it. Then you have it. You implement in our source code. The purpose contain the actual implementations. The source code contains our actual implementations. You can see from here, we include the stdio and the other one, what? My header.h. That's as demonstrated for us. You can see this is inclusion guard to check for us. If not define this. We have a function prototype here. We declare this, and you can also just look at this code and compare it as well. Then, okay, I want to finish the slide so that it can. Okay, we have this. So we also have what include this my header file. That's the sample code I want demonstrated. We now include it here. Can you see? You have it here, so you can demonstrate just same code example, and that is the end. We'll now compile them in case you're having multiple header something and you want to do them separately. You can compile them. You can even make use of what we call. You can also make use of. I've forgotten now. compile them into one file, just one file, and we compile everything. Is this make file? You compile, yes, you make it a make file. Make file, you can do that and compile everything for you. You can also look at the difference why we have this. A majority of this time we use Pragma. You are developing maybe to higher courses in future into microcontroller development using PIC MP Lab. You'll be seeing that you see a lot of Pragma define some kind of custom value import from the library for each microcontroller. You use this a lot in MP Lab to provide additional often compiler specific instruction or information to the compiler. It's a low and final control over compilation that is not. You can check the definitions and compile. I just need to include it there for you to have some information about it. So you can see the table. Continue. So and that's all. And that's all. Thank you very much. Please, I'm very sorry for the slide taking too long. Have a wonderful night. Please share, like, subscribe. Bye bye. Thank you.